Next factor, solubility of solids in liquids affected by the second factor, that is about temperature. Here the temperature influenced by the nature of the solubility. If the solubility of the substance is of endothermic reactions, if solubility is endothermic process, increase the temperature, solubility also increases. That's why temperature and solubility is directly proportional for endothermic reactions or endothermic nature. Whereas if solubility is a exothermic process, here the temperature and solubility are inversely proportional. According to Le Chatelier principle, for exothermic reactions, low temperature is favorable. Endothermic reactions, high temperature is favorable. So on the basis, here temperature rises, solubility also increases for endothermic reactions. Whereas here temperature rises, the solubility is decreased for exothermic reactions. Because of, here the solubility is applying for saturated solutions. Saturated solutions, what happened here? Equilibrium state is established. So, we are using of saturated solutions. In saturated solutions, what happened here? Solute plus solvent gives rise to here solution. So, in this process, here equilibrium state is established in between dissolution process as well as crystallization process. Here two processes are takes place. One is a dissolution process and second one is a crystallization process. So both are takes place. So the dissolution means here the solute dissolved in the solvent, formation of a solution is called dissolution process. Crystallization process means here the separating of the solute particles from solution is called the crystallization process. So that is here both are takes place simultaneously by equal rate. At a equilibrium state, the maximum amount of the solute can be dissolved in a given amount of the solvent is called a solubility. That's why here it is a equilibrium state. So that is why Le Chatelier principle is applicable for equilibrium reactions. That's why it is a physical equilibrium. So even though the physical equilibrium as well as chemical equilibrium reactions are applicable for Le Chatelier principle. So that is why you are applying as for Le Chatelier principles. If the process is endothermic process, the temperature is directly proportional to solubility. If the process is exothermic process, temperature is inversely proportional to solubility. So for example, you can take ammonium chloride NH4Cl is dissolved in the water to form NH4 solution. So the formation of NH4 solution, this process is in the forward direction. Here what happened? It is a heat absorbed. That means here endothermic process. So in this endothermic process, what happened here? Temperature increases, the solubility is also increases for ammonium chloride. But whereas sodium hydroxide can take NaOH is dissolved in water to form NaOH solution, aqueous solution. In this process is a exothermic process. It is a exothermic process. Therefore, here temperature and solubility is inversely proportional. So the one of the example can take in the process of dissolving of ammonium chloride is a endothermic process. That's why when the temperature rises, the solubility of ammonium chloride also increases. But in the case of sodium hydroxide solution, increase the temperature, the solubility is decreased. Why? Because this process is a exothermic process. That is why, according to Le Chatelier principle, the effect of the temperature on solubility of solids in liquids. But whereas the effect of pressure factor is neglected because of your dissolving of the substance of solids. So you know the effect of the pressure for solids is very less, that compared to liquids and gases can be negligible. So that's why here the solubility of solids and liquids affected by two factors. One is nature of solute and solvent. Second one is about temperature factor. Next goes to solubility of gas in liquids. Solubility of gas in liquid. Now, you know, most of the gases are soluble in water, like carbon dioxide, hydrogen, nitrogen, oxygen. Especially here the comparison of carbon dioxide, the solubility of oxygen is less. You know, the sustaining of aquatic animals because of your dissolving of oxygen in water. So that's why here the most of the gases are dissolved in the water. Here also influence of the factors, solubility of gas in liquid. What are the factors influence? One of the factors is here also nature of solute and solvent. In this case also, like dissolves like concepts only applying of your dissolving of gases in liquids. So here like dissolves like means the force of interactions between the solute particles as well as in solvent particles becomes equal. Then only the gaseous substances are soluble in the suitable solvents. So that is why like your solubility of solids in liquids, here also nature of solute and solvents are influence of the factors of like dissolves like dissolves like. The same concept applying in the gases in liquids also. And whereas second factor is about here temperature. Here the solubility of the gases in liquids always is considered as a exothermic process. Like the solubility of gas in liquids is like is condensation process. Condensation process, what happened? Vapors are converted to liquids. In this case also the gases are dissolving, converted to liquid states. That's why it is a process is always exothermic process irrespective of the gases dissolved in the liquid. So therefore here exothermic process according to Le Chatelier principle, what happens here? Increases the temperature, the solubility is what happened? Decreases. That is why here temperature and solubilities are inversely proportional always. Next factor. Third one factor is most important, that is effect of the pressure. So here the effect of the pressure on the solubility of the gases, the quantitatively relationship was proposed by the Henry's scientist. He was found a quantitative relationship between pressure and solubility. So here the solubility is measured in terms of mole fraction. It is measured in terms of mole fraction. You know, various concentration methods. So one of the measurement of the solubility with respect to mole fraction. That is why Henry's found a relationship between pressure and mole fraction. So now what is the statement of Henry's law? Here thus Henry's law stated as the partial pressure of the gas in the vapor phase is directly proportional to the mole fraction of the gas in a solution. What is Henry's law? The partial pressure of the vapor phase is directly proportional to the mole fraction of the gas in the solution. So it is stated as Henry's law. Partial pressure of the gas, that is P, directly proportional to the mole fraction of the gas in a given solution. So that is why you write about P proportional to X. Then it write about also P is equal to KH into X. Here KH is called Henry's law constants. Henry's law constant. X is equal to mole fraction of the gas. P is equal to partial pressure of the gas. So that is a KH and X. From this formula, from this equation, otherwise from equation 1, here KH is equal to right about P by X. Therefore, you write about the units of KH. Pressure units. The pressure units are becomes atmospheres or bars or even pascals also. Because of mole fraction having no units, that's why the units of KH are either atmospheres or bars or pascals. Here observed also KH and X at a given pressure or at a constant pressure, at a constant pressure P, what happened? Here KH and X are inversely proportionals. Therefore, KH values increases. What happened here? Mole fraction decreases. Therefore, KH values also increases. Here the solubility, what happens? Decreases. So, because of mole fraction is one of the measurement for the solubility of the gases. That's why KH increases, mole fraction decreases. Nothing but here KH increases, so solubility becomes decreases. So the KH and solubilities are inversely proportionals. Next, here KH is Henry's law constants. So these constant values, again, here KH values, KH values are depends on nature of the solvent and temperature. So different solvents having a different KH values, but not for all are same KH values. Different solvents having different KH values at a given temperature. Whereas temperature increases, KH values also increases. So that means earlier you know what is the effect of temperature on solubility? Temperature increases, solubility decreases. Temperature increases, KH values increases. But here KH and solubilities are inversely proportionals. So that's why temperature is directly proportional to KH, but KH is inversely proportional to solubility. You know, indirectly temperature is inversely proportional to solubility. So that is why here the KH values are depends on nature of the solvent as well as temperature. So every solvent have a particular constant KH value. So as well as depends on temperature also. So the temperature increases, KH values also increases. But KH values are increases, the solubility becomes, what happens? Decreases. So that is a Henry's law constant you are using to calculate the solubility as well as the units of Henry's law constant. The Henry's law constant values are depends on nature of the solvent as well as temperature. So next, here some applications of Henry's law. So what are the applications of Henry's law? Henry's law, one more statement also defined here. Here already one of the statement is partial pressure of the gas is directly proportional to mole fraction of the gas. as well as it is also defined as here increasing the pressure of the gas, the solubility of the gas also increases. So what is that? The pressure of the gas increases, the solubility of the gas also increases. That is another statement at a given temperature. So then here applications of Henry's law. So what are the applications of Henry's law? So one of the application here, beverages, manufacture of drinks, either soft drinks, nothing but here cold drinks or hot drinks, here bottles are sealed under high pressure. Why? Because under high pressure the solubility of CO2 gas is more. So that is why to increase the solubility of CO2 gas in the soft drinks or soda water, the bottle is sealed under high pressure. Bottle is sealed under high pressure because solubility of CO2 is more under high pressure. That is one of the application. Whenever seal the beverage bottles, applying of high pressure. At high pressure, the dissolving of the CO2 gas is more. That is one of the applications applying in Henry's law. Second application, at high altitudes or at a high altitude, what happened? The partial pressure of oxygen is less than at the ground level. Therefore, what happened? Here the concentration of oxygen in the blood and tissues of people living at high altitudes, low blood oxygen causes symptoms of anoxia. One of the disease, anoxia. Why? Because here at higher altitude of the peoples are available of atmospheric oxygen is less. Due to available of less oxygen, it becomes what happened? Here concentration of the oxygen in the blood as well as tissues becomes living high altitude. So it causes the symptoms of anoxia. Next, one more application here. To avoid the Bend's diseases, BENDS, Bend's diseases in scuba divers. So in scuba divers, using of the oxygen cylinders, they are also containing nitrogen gas. So that's why here this gas is diluted with helium. Diluted with helium gas. So what happens here? Here dissolving of helium becomes more in compared to nitrogen gas. So whenever inside the water, then the solubility of here oxygen and nitrogen becomes increases. So that's why the scuba divers must be here. What happens here? Using of the cylinders here filled with the oxygen along with the helium gas also. So whereas the nitrogen is present in blood, it becomes the blocks of capillaries are creates a medical containing of disease is known as the Bend's. It becomes a painful, dangerous to life. To avoid the Bend's disease as well as the toxic effects of the higher concentration of nitrogen in the blood, the tanks, the cylinders or tanks are used by scuba divers are filled with air diluted with helium. Therefore, here the percentage of helium is about using of 11.7% of helium and 56.2% nitrogen and oxygen is about 32.1% of oxygen. So this composition of the substance are used in the oxygen cylinder. So that is to avoid the Bend's disease, the cylinder should be filled with these nitrogen, oxygen along with the helium gas also. That's why to dilute the air, you are filling of helium gas. So these are the applications of Henry's law. What are applications? First one is here the beverage bottles are sealed under high pressure because of the solubility of gas is more under high pressure. Second one is in higher altitude peoples are becomes available of oxygen is less compared to ground level. Therefore, the concentration of oxygen is less in the blood and tissues of people. So therefore, low blood of oxygen causes climbers to become weak and also unable to think clearly. These symptoms of known as the anoxia. And third one is about Bent's diseases. To avoid the Bent's diseases, the air cylinders are diluted with helium along with nitrogen and oxygen. The composition of the helium is 11.7, oxygen is 32.1 and nitrogen is 56.2. So these are the applications of Henry's law.